Welcome to the last video in the chemistry topic. This video is on word equations. Chemists often use word equations as a way of quickly informing us what the reactants and products are in a reaction. These two words are really important, so I'll get you to write down the information in this box down here. Reactants. They are a substance that takes part in and undergoes change during a reaction, the reactants. The products, on the other hand, the products are the substances that are formed during the chemical change. Pause the video here for a moment and copy what's in the red box down. Like mathematical equations, chemical word equations are structured the same throughout the world. We call this a scientific convention. The names of the reactants are always on the left. Then there's an arrow which means react to give. The names of the products are always on the right. For example, let's look at the two down here. We've got magnesium and copper oxide. These two substances are on the left, therefore they're called the reactants. Magnesium and copper oxide are the reactants. This arrow here means reacts to give. And on the right hand side we've got magnesium oxide and copper. These two substances are the products because they're on the right. Let's have a look at this second equation. Steel wool, which is made of iron, and copper sulfate are on the left hand side, therefore they're the reactants. Iron sulfate and copper, they're on the right hand side, therefore they're the products. As you can see from these word equations, rather than using words like and, we use a plus instead. Rather than using words like react to give or combine together, we use an arrow. There's some of the key hints that you're looking for when you're turning a word equation, a sentence into a word equation like this. When writing word equations, it's really important to identify the states of matter. It assists the reader if you can communicate these of both the reactants and the products. To do this, the scientific convention is as follows. A solid is identified by the subscript, that means lowered down below the normal characters, of an S. A liquid is identified by a subscript L. A gas is identified by a subscript G. An aqueous solution, which is a substance dissolved in water, is identified by a subscript AQ. These go after each of the elements or compounds in the word equation. Here's some for you to try. Rewrite the following sentences as word equations. Let's read them together. Magnesium burned brightly, reacting with the oxygen in the air to form magnesium oxide. Now the second one. Hydrochloric acid reacted with the calcium hydroxide to give water and calcium chloride. The final one, hydrogen gas and oxygen gas combined to form water. Pause the video here and take a moment to rewrite these sentences as word equations. Look for reactants, look for the words like react to give or combine to form, draw an arrow, and then the products on the right hand side. How'd you go? Let's have a look at them together. So the first one was magnesium burned brightly, reacting with the oxygen in the air to form magnesium oxide. Magnesium plus oxygen reacts to give magnesium oxide. Pretty straightforward. The second one, hydrochloric acid reacted with the calcium hydroxide to give water and calcium chloride. We've got hydrochloric acid and calcium hydroxide as the reactants on the left hand side, and they reacted together, hence the arrow, to give water and calcium chloride as the products. This was a bit of a tricky one because reacted came before the second reactant, which was calcium hydroxide. You need to read these sentences carefully in order to get the reactants on the left and the products on the right. The last one, hydrogen gas and oxygen gas combine to form water. This is pretty straightforward. Hydrogen plus oxygen reacts to give water. Now that you've watched this video, feel free to watch it as many times as you like. You can pause, take notes in your exercise book, rewind and watch again if necessary. Take note of any questions that you have. We will have plenty of time in class to discuss these. It's really important that after watching these videos, any questions you bring to class. In class then, rather than taking notes, we'll be practicing the skills covered in this video. We'll do this individually, in small groups and as a whole class. I'll give you some worksheets and some practice word equations that you can write in class. For those of you that are interested, hang around because the next slide I'm going to show you how to do some balancing of equations. So this is optional. You don't have to know this and it's not required for the Year 8 curriculum, but it comes up when a lot of students begin to realise that some of these equations don't actually balance out. What I'd like to do is take you through how we actually balance the equations in chemistry. So if you have a look at this first one here, we've got magnesium and oxygen react to give magnesium oxide. This is the elements to compound practical that we did in class. If you look on the left hand side, you've got magnesium, and then you've got two oxygens, oxygen gas, and these react to give magnesium oxide. Now there's one magnesium element here, one magnesium atom over here, two oxygen atoms here, and one oxygen atom here. This is obviously not balanced. There are more atoms, there are 3 atoms on the reactant side, and there are only 2 atoms on the product side. This is an unbalanced equation. We need to make it balanced. To do this, we start by looking at, we've got 2 oxygens on the left, and on the right here we've only got 1. To make 2 oxygens, we can put a 2 in front of the compound magnesium oxide. This gives us 2 oxygens, but it also gives us 2 magnesiums. Now if we look, we'll notice that we've got 4 atoms on this side, 2 magnesiums and 2 oxygens, and on this side we've got 1 magnesium and 2 oxygens. We've only got 3 atoms. To balance that out, if we put a 2 out the front of this magnesium atom, we'll end up with 2 magnesium and 2 oxygen atoms giving 4, and 2 magnesium and 2 oxygen giving 4 on the right hand side as well. Now our reactants and our products are balanced. Let's have a look at a harder one. Iron oxide plus carbon reacts to give iron and carbon dioxide. This is the chemical equation that happens in the blast furnace in the production of iron from hematite or bauxite. On the left hand side you've got 2 iron, 3 oxygen plus 1 carbon react to give 1 iron atom, 1 carbon atom and 2 oxygen atoms. Let's look at the oxygen atoms first. The lowest common multiple of 2 and 3 is 6. So in order to get 6 oxygens on the left hand side, we multiply everything by 2. On this right hand side with the carbon dioxide, to get 6 oxygens there, we multiply everything by 3. Now you'll notice that we've got 3 carbons on one side, the right hand side of the products, but only 1 carbon on the left. If we put a 3 in front of this carbon, we now have 3 carbons on the left, 3 carbons on the right. We have 6 oxygens on the left, and we have 6 oxygens on the right. You'll also notice though that we have 2 groups of 2 iron, or 4 iron atoms. So in order to balance out the reactant side with the product side, we put a 4 in front of the iron atom. So now we have 4 iron, 6 oxygen and 3 carbon, with 4 iron, 3 carbon and 6 oxygen. Both sides are balanced out. If you'd like some more information in regard to balancing equations, speak to your teacher. Have a great day.